So today we're going to issue drawing number 5. Um, and let's review also homework number 12. There, homework number 5 is our last drawing. I mean, drawing number 5 is our last drawing. And it should be pretty simple. We're going to use a couple new tools here. So let's go back to our syllabus and modules, sorry. And then the idea on the homework was to review these tools called taper faces, flat shot. We already looked at shell and taper faces. Let's open our drawing and we'll kind of work over that again, and then we'll start working on the next drawing right away. Okay, so the content that we've been doing. Focus maybe on this one here. And yeah, we use that to do that taper faces tool. And so let's do that again. Taper faces. Tapers a face on a 3D solid at a specified angle. A positive angle faces taper the face in and then taper the face out. And so all default faces in the selection set are tapered to the same value. So click on that, press enter, click here and at the top, and then I'm going to do -35, and it tapers out. Let's do the same and do 35. Taper faces, select the face, enter, click here and there, and then 35. And it tapers the face inside. So that's what taper faces can do. The next question was to do a flat shot. Let's see what the flat shot is. Flat shot creates a 2D representations of all 3D objects based on the current view. The edge of all the 3D solid surfaces and meshes are projected line or side onto a plane parallel to the viewing plane. The 2D representations are inserted as blocks on the XY of the UCS. And this block can be exploited. So if we have an object like this, the flat chart will create an outline um, of the object that we can use for presentation purpose, right? And so ideally, you may have used this tool to create your final project, right? So um, let me copy this object here. And maybe we create a flat chart. Let me make sure that we don't have the history here. Okay, so now we got that, and I'm going to do flat chart. And flat chart is this icon here. Let's see, where do we find the flat chart icon? Fine. Flat chart. Okay, let's see, where is our flat chart? Right there, under section plane within the add jog as well. And attract edges and all that, but we should also have it right here. So let's see. That's interesting. It's only here. Okay, so I select flat chart and insert as a new block, export to a file, and include tangential edges. Let's do create. And it's creating a flat chart of everything, right? Interesting. So just click there, 1, 2, 3. And it's not exactly what I like to see, because I wanted to see just the wireframe view of the object I created. So let me do this again. And to make it easier, let's select this object, clipboard, copy, and paste. All right, so let's do flat chart. This time I'm gonna do tangential edges, create. No, that's not what I want to see. Let me look at the options here. Yeah, that's kind of what I want to see, but it's Yeah, it's creating the object I want, but it's now let me see it this way, and let's do the UCS right here. Yeah, that's better. Okay, and let's do this. No, X, Y. Base point. Let's see base point right here. Rotate. Not really what I want to see, because what I want to see is, let's see, obscure lines. Those are the ones that are behind that I will not typically see. Tangential edges. That's fine. We don't have a problem with that. Let me do this. CCS plan. And let's do the flat shot here again. Yeah, see that's exactly what I want to see. Now let's go back to 3D and let's do the flat shot again. It's just not placing in the right place. But it is doing what we want it to do. So okay, well, that's the flat shot view. Ideally, I like to see it more like this one, right? That it starts right there, X. Okay, X, Y, and Z, right? So, still not. Onto a plane parallel to the viewing plane. So parallel to the viewing plane. Right, so let's do a flat shot. Click this, and now let's go to a side view, top view, from view. And that's what I want. There we go. So we need to be on the X and Y UCS on the floor. And now I can create the flat shot. That's what I wanted to see. And so let me try to do one more thing here. Okay, so I'm going to do another flat shot. Click OK and place it there. So it's in the right place. And now when I go to the layout and I do plan, and in the plan view, then the flat shot shows correctly. That's what I'm looking for. Let's give this flat chart color, let's give it a different color. It's a block, so you cannot change it right like that. But if I select the block editor, great. And here what we can do is change it here. Great, close it, save it. And you can see the object there. So that's exactly what I want to see is a view of the object edges as I took it from that particular location. Go back to model space. See, that's what it looks like from that point of view. Now, if I were to take a flat shot of this, and place it there, okay? So, now I can open okay, and so now I can go to here, and there it is. Now selecting, edit block, and just change the color so that we can see it better. Great. So, so the key here then is to once you place the flat shot, then on the viewport of your presentation, then you go to the world UCS on X and Y, and then you'll see the block in the right way, the way that you intended to see it. So that's the idea. Okay, so the next thing that we have in that particular exercise is to create a jog section, right? And so we got our object here, and so let's try to find that out. Jog section. And so the jog needs to be applied. So adds a jog to the section object. And so we have the section plane. All right, so let's do section plane. And we're going to draw it right here. Now I'm going to go to 3D. And we can add a jog to that plane. And that jog can be modified by modifying each of these. And we can see the geometry that is being cut away. Modify the jog. Hard to modify here because we're selecting so many objects. Let's no gizmo. Let's go to 3D and see if I can do that from 3D. There we go. So it's a little hard to select the section unless you are on a 3D wireframe. But so I can modify the section by creating a jog on the section plane. And so as you can see, then, oh, let's move that one in a little bit. Because there is a plane here. Now we can see it better. And so the section, what's happening is that the section plane becomes disjogged. And I saw your homework, so you did it correctly. But that's the section plane now, which it's got a jog there. And if I were to do a generate a section and do a 3D block, then we can see that jog there. Right, we can see how the object was, how the section is basically taking out this whole corner as a section. Very powerful tool to do presentations and sections that we need to visualize, right? Those are my flat shots, and I'm going to copy this here. And then on this one, I'm going to focus on that and go to a 3D. I don't see my UCS. There it is. And we can see the object then that has the flat shot created. The jog section there. And those can be all part of my presentation as we continue to work on our project. All right, so now we're going to do, I think that's it. I think that's what we needed to do. Yeah. Um, Now, what we're going to do is talk about drawing number 5. And that's the last drawing, as I said. And in reality, is the final part of this project that we've been working on since a couple of weeks ago, right? And so in my case, I was doing this architectural project, and I decided to select one object as my detail. And so now I am going to just focus on my detail. So let's say that this is the detail that I am going to do. And so first thing I'm going to do is save this drawing, and now save it again as drawing 5. 3D modeling drawing 5. And in drawing 5, I am going to delete everything else except that detail that I have. And maybe move that detail within the UCS world, and move it kind of somewhere over here in the positive area of the UCS, right? Go back to 3D, zoom all, and world UCS. Okay, so, and that's what we should have in our drawing 5, is this particular object, or whatever our object is that we decided to create it. And so in this case, let me move this because it probably made more sense to move from here to 0, 0. Okay. And I need to, let's look at the assignment, right? The assignment is drawing number 5, or final project. It says here, using your file from drawing 4, just show you how to do that. Create a 3D model of a detail, the component from the previous projects, applying solid modeling as needed. Provide as much detail as you can in your 3D model. So here, the idea is that you could go in the next 2 weeks, because the next 2 weeks are the last 2 weeks of class. In the next 2 weeks, you will develop the project to the finer degree of detail possible, or as much as you can, right, within the time frame and the time that you have for to work in a class. But what does that mean? Well, it means that you need to explore the detail that you have. In my case, this is a window from a particular building, and see what level of detail do you need to go? What does that entails? And for me, as soon as I get, I wasn't sure I was going to do this window, but as soon as I get to that, I'm kind of plotting a course that I want to be on. And so we're going to use these 3 tools, or 2, actually 3, but for now we're going to use only 2, Solve View and Solve Draw. And these tools are very specific tools that are going to allow you to create 2D drawings of the model that you have. And so right now, this model is a pretty simple object, and that's fine. But now I need to give it more detail. And one of the ways I have to do that will be to look at this original project, actually, right? And I know this building, I know which building it is. So let me see if it's got more detail. And what is the detail that it needs to, or that it has? I'm going to see if I can find some images of that particular window as it got built. Which I don't know if I can find them, but maybe. That building in particular, the one that I'm doing, was a very famous building architectural wise. And so that's what I was thinking, that I may be able to find some info about it. There's a picture here, but really doesn't tell me much more about that. See, the windows pretty much, although no, I you know, I can get back to this because the window, which is on the other side, should be similar to that. And it seems to have a casement window on one side and then a fixed window on the other. So that tells me that there is a lot of detail that I can um, have in this particular window. And actually also on the first floor, on the other side, this is an addition study. I can see that this window is divided in two. It's got a little kind of ventilation box, I think, or something strange. I don't know. But maybe I can do that. I can add more detail that way. So there are many things that I could do. So just the fact that it is a casement window instead of a regular window, that gives me a lot of information because I can look at casement window, right? Casement window. And the casement windows have a lot of hardware that I should look at because I should then now create that hardware as part of my 3D model. And see, I'm looking at a casement window now, and it says here, operator and operator handle. So for this particular project, then I should start looking at creating all of that as part of my window. So a simple project really becomes very complex because now I need to look into the details that make it up. And look at that, all of that is part of that hardware. And do I want to do that? Well, I should try to do something like that. Even if it's hardware like this, which is pretty simple, it is a complex object, much more complex than just the window. And I should be able to do that. So what I'm trying to say to you is, and this one, see, this one's got a crank. So I need to decide which one I'm going to do. But what I am trying to do, to say to you right now is that for this next project, then analyze the object that you have as a detail and try to find out a level of complexity for the detailing that is coming that you want to handle. And then we'll start working on that, right? But that's the idea. That's what you should do at this point in time. Then the final presentation is going to include plans, elevation sections, shaded views. We're going to use SolveView, SolveDraw, and then there's another tool called SolveProf that we're going to learn. And then in the final presentation, you can also use Flatshot, for example, because that's going to give us a really good drawing. And that's that. As I said, that's the whole project. And what SolveView and SolveDraw are going to do is that they're going to allow us to create 2D views of this object. And those 2D views are generated from the 3D model, and the computer draws them. The computer creates the 3D view, the 2D views for you by using these tools. And so let me give you an example of that. I'm going to open a new drawing. And in this new drawing, I am going to create a simple 3D object. Something like that. Maybe I select another primitive here. And then let me move this object. UCS by view. Let's do a wireframe, and then I'm going to move it from there to there. And then maybe let's create a different one here on this other side, maybe a cone. Turn off dynamic UCS. And there we go. I'm going to go to this view. And UCS by view. It may be, let me mirror this object here. All right, great. So I got a couple of things that I can work with. And now I'm going to type SolveView. See what happens when I type SolveView. It sends me to the layout tab, and then I get this prompt that says enter an option, UCS, ortho, auxiliary, or section. So what's happening is that the computer is asking me what kind of view I want to create, because the SolveView tool is a tool that is there to create views. And these are the options. And so I am going to select orthographic projection. And maybe I select orthographic projection from this side of that object. Remember that orthographic projection has 6 sides minimum. So I'm going to select this one here, move my cursor, then click where I want the center of the new view to be. And now I press enter. Now I create a viewport there around the center that I define it. And the view is created, and I give it a name, right side. And click enter. And enter again. Now I can click outside and end my work. So see, I just created this view. This view is an orthographic projection of this object seen from here, right? And so that's what the computer created. And this is a solve view, right? It's called right side. Now let's look at the layers so that you can notice something that's happening. See, the computer program is also creating these layers by itself. And we're going to have layers for visible lines, layers for hidden lines, right? Let me load a hidden line type. And select hidden for that. Now let me apply the other tool that we're learning to use, which is called Solve Draw. Click on the object, press enter, and now you can see how the computer generated this view, which is just a 2D view. Now these are just lines. And you can see that some lines are actually hidden lines and some lines are visible. So the computer figured out everything that you needed to create that view. And then all of those objects are in the right layer at the time. So with Solve View and Solve Draw, we can create any views that we need. Now, of course, this view is like that because it's a view from this side. Now, what happens if I modify the location of this object, right? And so from the beginning, I'm sorry. Let's do that from the beginning. I'm going to undo everything, right? And in here on model space, before I do anything, I'm going to go to top view. And now I am going to type Solve View again. And I'm going to create an orthographic projection. Again, from the right side, click where I want the center to be. Now enter, create the viewport. And now give it a name, right side view. Press enter, and then you can just escape and end the selection. Now let's rotate this viewport, right? And see, this is a side view of that. If this were a building, then this is the right way of presenting that building. So let me do one more thing here. Oh, it's too big. And say that that's the floor, right? So let's get back here. And you can see where the floor is. So this is an elevation view. Now, what happens if I do Solve Draw now? Let's go to the layers and also reload this hidden line because it will be better if it's loaded, if it's preloaded. And now we do Solve Draw. And now you can see that that looks more like an elevation or side view of that object. And that is all a 2D line work that then I can use to create my presentation. If I need to do side views of elevations, this is my side view and elevation, right? And I didn't need to draw all of that. The computer did all the drawing for me. And that is kind of going back full circle to where you were when we started our 3D project, because for the 3D project, we created plans, elevations, and sections. And that's the same thing you're going to do now, but from the 3D to 2D. And that's the project for next, that's the process for next project. That'll be all for today. Thank you very much if you were here, and I'll see you next time.